In the previous video, we have assigned all the member loads. Today, I will start with the steer load. So for steer load, I will select only the steer block. At first, I will go to the beam cursor and will select this steer block and will go to view selected objects. And again, I will select beams parallel to Z, and again I will view selected objects. I will go to front view and select all the beams where I will assign the steer load. So I have to assign the steer load on all these beams plus this beam. So you can see that all the beams where I have to assign the steer loads are selected. Let's see what is the load coming on steer. I have calculated here that the dead load at both end for steer is 21.56 kilonewton per meter. 21.56. So at dead load I will add as member load minus 21.56 and add. I will close this, select this load and assign to selected beams. So the steer load is assigned. Now I will assign all the floor loads on each floor. So floor load will be assigned in some different way. That when I will add the loads here, it will be directly assigned. I have not to assign this as member load separately with selecting all the beams or any other way. Just for the floor load, I will specify some range that from x direction from 0 to something distance, or z direction some distance to some distance, and y direction as well. I will specify some range. By that range it will be assigned. Like the floor load will not be assigned for this stair block and this lift block, so I have to assign the floor load separately for different block. I will assume this is my first block, so I will assign here. Thereafter I will assign on this middle block. Thereafter I will assign here. So for that I have to check what are the ranges. For this I have to check here. In that case I have to select the node cursor. So this is my 0 0 0 point, means here I will check only the x and z value 0 and 0, and here I will check the x and z, that is 25.2 and 5.2, and again I will go to front view and will check the y value. I will put from first floor to the roof because in the ground floor the floor will be rest on the soil, so the load will not be transferred from the floor to the beams. So I will only assign from first floor to the roof. So here the y value is 4 and at top the y value is 31. So I have already noted down those range here, and the total dead load from slab that is coming as 3.875. So I will assign that. In that case I will click on this dead load and add. From here I will select now this floor load. the pressure will be minus 3 point, what is the value? I have to check. 3.875. 3.875. Now I have to input the range here. After inputting this range, it will be automatically assigned. So y range is 4 to 31, x range is 0 to 25.2, and z range is 0 to 5.2. The direction will be global y, and it will be y range, and add. So here this load is added. Again I will add for the mid block. The mid block, there is, it is x range is 6.3 to 18.9. Let's put this 6.3 to 18.9, and z range here is 5.2 to 8.7. 5.2 to 8.7. I will add this, and for the third block it is 0 to 25.2 and 8.7 to 15.3. 8.7 to 15.3, and x will be 0 to 25.2, and add. So all the floor loads are assigned. Let's see. Yes, the floor loads are assigned as trapezoidal way and triangular way. So you already know that the how floor loads come on the beam. For the longer direction, the load is coming as trapezoidal form, and for the shorter direction it comes as the triangular form. So you can see that the loads are assigned in all the floors. Now some more floor loads I have to add for this roof and the machine room. So here I have to check the range. So for this, the Y range is 32.7. So I will go to dead load, add floor load, that will be 3 point negative 3.875, and that node is 32.7. Here only for this floor I am assigning, so I will only input 37.4. I, yes, right, 37, sorry, 32.7, 32.7, and the top one is 35.2, and this is in between those 33.5. Here I will not specify any range of x and z, because for y range 32.7 to 35.2, for all the floats I am assigning this load. So just I am adding this. So this load is assigned only here, because no beams are added here, so the middle portion is not specified as any slab or block, so the loads are only assigned on this part. So here all the dead load assign is completed. Now I am going towards the life load. The life load will be assigned similarly as floor load, because the life load will come only on the floor, only from the floor, not from any member, because that are the permanent members as dead load. So I will assign life load only for the floors. So at first I have to specify some zone, means for this part, again I have to select the beam cursor. For this part I have to assign for the shop loads, that I will assign as 4 kilonewton per meter square live load. This is foot block, here also I will assign 4 kilometer per meter square. For the corridor I will assign some more load than the shops, like I will assign here as 5 kilonewton per meter square. These are all the floor for shop. So here also I will assign 4 kilonewton per meter square, and for this washroom I will assign only 2 kilonewton per meter square, because here the life load will not be that much heavier. So here I will assign as floor loads. So I am assigning the live loads as floor load. Okay, before assigning I am going to the front view. The live load will be assigning from first floor to this floor, not on the roof. The roof live load will be assigned separately. So I will assign up to this. So here I have to select the node cursor and check the height, that is 28. So live load, add the floor load as -4, that is 4 to 28, and here the x range will be 0 to 25.2, and z range will be 0 to 5.2. View, top view, here I am assigning for this part only, because here all the shops and food courts are having the same live load as 4 kilonewton per meter square. So I am assigning all together. So I am adding. And for the mid blocks, the second block is 6.3 to 18.9. 6.3 to 18.9, and that is 5.2 to 8.7. Let's check again. That is 5.2 to 8.7. It is okay. And for the corridor, I have told that the load will be much higher than the shops. So here I am assigning as 5 kilonewton per meter square. Add. And for the below portion, here I will assign separately for the shops and for this washroom. So here I have to check the range, that is 0 to 18.9, that will be x will be 0 to 18.9, and z range will be 8.7 to 15.3. Here the load will be 4 kilonewton per meter square. Add. And the last, this washroom, here the load will be from x range, that will be only change 18.9, and 25.2, and that load will be very less for washroom, that is 2 kilonewton per meter square. And add. For machine room also we will assign some load that will be little bit heavier. So here the Y range is 32.7, Y range is 32.7, 32.7. Here I have written the minimum and maximum same as I am assigning only for that floor, not in other floors. And here X range will be this 25.2 I have assigned as little bit higher, so I have to edit there. Before that I am changing here only, that is 5.2 to 8 point, and the machine room load will be little bit higher as 5 kilonewton per meter square. Add. So here all the loads are added, you can see here. This will be only 25.2, and I will modify this close. So all the life loads are assigned. Now I will assign the roof life load. For roof life load, we have to check which roofs are accessible or and which are not accessible. For accessible roofs, we will assign 1.5 kilonewton per meter square load, and no, for accessible roof, we will assign 3 kilonewton per meter square, and for non-accessible roof, we will assign 1.5. So for only the accessible roof is this block only, and non-accessible we will assign for this. So I am assigning the roof life load. Add the floor loads. Here the Y range will be 3131, and the load will be minus 3. Or we can assign a little bit less life load on the roof, because it is a shopping complex, so their load will be not much higher, so we can assign as 2 kilonewton per meter square also. And X range will be 0 to 25.2, Z range will be 0 to 5.2 for the first block, and for the second block Z range will be 5.2 to 8.7, and X range will be 6.3 to 18.9. Add. And for the last one, third block, it will be X range will be 0 to 25.2, and Z range will be 8.7 to 15.3. So add. So here loads are assigned on the roof on these blocks, and now I will assign the loads for this and this roof. And here I will select only the Y range, and here I am assigning 1.5, only the Y range. This is 33.5, and this one is 35.2. Here I am not assigning the X and Z range, as I have told earlier. There is no roof except those, so I am adding this. So here the loads are assigned as roof loads. So till now what we have done in the load cases, that I have assigned dead loads, live loads, roof live loads. Now it is the time to assign the wind load. For wind load, we will prefer IS 875 part 3, and here I have calculated the wind load. So for the wind load I have need the basic wind speed K1, K2, K3, K4. Those are given in the IS code. You can see there, and the from this VB K1, K2, K3, K4, you can calculate this VZ as VZ equal to VB K1, K2, K3, K4, and from VZ you can calculate PZ as zero point 0.6 VZ square. Thereafter you can also get the KA, KD, KC constant from the code, and from there you can get the PD. The PD is PZ, KA, KD, KC, and this K2 is calculated from the terrain category. As uh, in the code it is given that for this height the K2 value is this. For this, here I have made this equation of this curve, and by that I have assigned this formula, and I have calculated this K2 value. And now I will add this PD value as per my height. So for that I will go to definition, add. Okay, uh, so definition plus, from here I will select this wind definition and add. Just I will add the wind load as custom. So add. Again I will select this type 1 and add. Here I will input the height and the intensity. So for height 4 meter, not required this 4, I will assign from 10. For 10 it is 0.91, 0.91. I am taking for 2 digit, and 10, then 13, 16, 19, 22, 25, 28, and 31. Now I will input those intensity. The next one is 0.99, 0.99. Then next is 1.04. Next is 1.08. Thereafter 1.12. Thereafter 1.16. Thereafter 1.2, and lastly 1.24. Just I will add this and fact. factor, no need to add. I have added this wind definition. Now I will go to wind load X, add. I will go to this wind load. Here I will specify the range from 0 to, let's assign up to 40. Like there is no 40-meter height part of my building, but it is in between 40 meters, so I can also I can input the exact value, that is 35.2. That also I can input. And x range, z range, no need. And the factor is 1.45. As this factor also I can get from the is code. In some other video I will describe how I am getting this factor and how I am calculating this k1 k2, all these things. And here I have assigned this range for y because this part is below ground level. If I did not specify the range, then the load will also act on this node. So to avoid this, I have assigned this range from 0 to top. So this is x windward direction I have add, and for negative x direction the factor will be just negative and add. Again I will add the wind load in z direction, similarly wind load, and for z direction my factor is 1.3, and that is in z direction. Same I will input the height as 35.2 and add. For the leeward direction I will input the factor as negative and add. Now you can see that all the loads are assigned. So here I have assigned the dead load, live load, roof live load, and wind load. In the next video, I will discuss about the seismic load. So for today, up to this.